Hello! Today we're going to take a look at game programming in Odin and see how easy it is, I guess. I tried Odin before, but I never tried it. I tried to look it for the embedded purposes in Odin, although Odin doesn't really support 16-bit or 8-bit architectures, only 32 and 64. So that kind of deterred me a bit from Odin, but I want to try it for game programming first at this point. And we're not going to do anything crazy. We're just going to try to do a snake game. Because a simple snake game kind of exposes us to a basic rendering structure and a really simple way to test the language for game programming, I think. Odin has a vendor thingy, and I think there is literally a Rayleigh binding in there. So I think we're gonna try to use that. Is it here? Yeah, vendor library. There's a lot of stuff here. There's DirectX, GLFW, Lua, Mini Audio, OpenGL, STL2 Raylib, STL3 as well. We're going to be using Raylib for this. So I guess let's just start. Programming Odin. Right. Raylib, or let's just call it Snake Game in Raylib. Odin. Package Snake Game. Is I hope that's alright to put in there. In Ada there is a concept of packages as well, and you have to kind of make it the same as the file name, but I hope it's not like that in Odin as well. I never tried, so we'll see. I also want to open the sources for the Odin here and take a look at the vendor directly from here instead of the web browser. So yeah, let's open. Where's the Raylib? Okay, Raylib. And Raylib.Odin. Okay. So there's the license. And it's just the direct bindings for Raylib, I guess. Window. Yeah, okay, yeah, it's literally direct bindings for Raylib. Okay, Snake Games. So I think we have to import it. Is it like vendor Raylib? I also going to put RL in here as an alias because typing Raylib each time is going to be too much, I think. And so we can start with our main procedure. Let's do it like this, and it's not going to return anything. So RL init window. Let's define our window size. I want the game to be 1 by 1. It's a snake game, so I just want to make a 1 by 1 screen and direct render there. Window size is going to be a constant. Let's make it 500. So we can just put it in here like that. Window size is going to take the width and height, and this is the height, and the title can be just snake game. And does it return anything, by the way? It doesn't return anything. Then we can just defer our that close window here. Then we will start with the game loop. For window should close. Yeah, it returns a boolean. Oops, window should close, not close. And this is the loop. Then we're going to be doing the basic rendering is the begin rendering, clear background, and the end renderings. We have to call these functions because otherwise Raylib is not going to pull the events for the window. I think I saw somewhere that we can pull them manually. Yeah, this one. We can pull them manually but we're not going to be doing that. We don't need to. I'll begin drawing. And I'm going to open a scope in here. I think it's supposed to be like this. And I'm just going to defer the end drawing in here, so you don't have to worry about this. And this is basically the rendering. This is the basic structure I go for when I program in Rail, in any language actually. I generally do this in C and Zig, and I will emulate what I normally do in Odin as well. Although in C you can't do differs, so you just put them at the end. Anyway, and we need to clear the background. Let's just put that in here as well, so it's kind of contained in a small part of this scope. RL clear background. Was that the name? Clear, yeah, it is the name. And there are colors here, I think as well. Yeah. Let's just make it black. There's black, right? Yeah. Okay. Let's just make it black. Is this how we use this? It is a constant, so it should be just like this. Yeah. And this is basically end of our render loop. And again, render loop is also pulling the inputs. I normally don't recommend doing it that way, but that is what Reddit does. So we're just gonna go with it. Anyway. Oh my god. Okay, let's run the program. So how do we run it again? Odin run. Does it require us to link with Raylib? Because I don't have Raylib in my system right now. I don't know. I guess we will see if we need to link with anything in here. Run snake game in Odin, and was it file? I think it was file. Oh, it doesn't require us to link with anything. How did that happen though? How does it know that we are supposed to link with Raylib? And where is Raylib, by the way? I don't have Raylib in my system. Wait, what happened? Is it literally comes with Raylib installed? Okay, let's investigate. Vendor. CD Raylib. Less Linux. Oh, yeah, it literally comes with Raylib binaries. Okay, that's kind of interesting. But how did it link with it? I didn't say anything about link thing. How do you link with it? There is. Okay, this is the Linux part. Foreign import lib. Imports lib. Linux Raylib. Oh, is it? So does this tell the compiler to link with these things? I think that's what it does, but how does that work? Um,
Oh
my connection was
bro.
interrupted. That's not good. Did my I think my internet just went out, or it failed to connect to stream or something. I don't know. So anyways, I don't know when it was, but I was looking for how Raylib or Odin links with Raylib, and I saw this thing. So let's take a look at how this foreign import syntax or semantic works. I don't know where it would be, but foreign system, yeah. Foreign system. It is sometimes necessary to interface with foreign code. You can import a library into the code using the same semantics as a normal import declaration. Okay. So this is an alias. It is the same semantics as a normal. So this is the alias for this thing. And it is importing literally this library from system, and that's the name. You can import assembly files as well. Huh. That's quite convenient. Okay. Nice. So it literally just imports the static library or the assembly file. That's very nice, actually. Yeah. Okay. Let's continue then. Let's define the grid. I want grid to be 30 by 30, and we need to draw the grid. So let's draw the grid. I think Odin has a range syntax. Yeah, okay, so this is inclusive and this is upper limit is exclusive. Okay, we're going to be using this syntax. For y in 0 to grid, I guess. And I remember there is a do statement that allows us to execute one line of statement after a conditional loop, something like that. I don't know exact definition of it, but it allows us to get rid of the parentheses here, I think. So I'm just gonna say do, and do loop through for the x as well. And this is going to be grid as well. And does this even work syntactically? Can you check for that? Wait. Okay. Can you build this thing? Okay, so it builds. So semantically and syntactically, this works. That's great. We're going to be drawing rectangle lines. So if I remember this correctly, yeah, it takes two arguments. They are position, width and height, and color. Position is what, well, we need to calculate the cell size first though. Yeah. And cell size is going to be calculated by dividing the window size to grid. That's going to give us the cell size according to the window size and the grid size. This is going to be x times cell size, and this is y times cell, and the cell is, let's do it this way. This is the width and height of the rectangle, and the color is just going to be white. So this is also one statement. Can I also put do in here? Does that work? No. The body of a do must be on the same line as the for statement. Huh, okay. So I'm just gonna use curly braces for this. It makes it better. So what's the other error here? Okay. Cannot assign value x times cell of type int to i32. I don't understand what.
A few moments later.
So there apparently int is not i32. What is int then? Types, basic types. Int. Uint pointer type is pointer size, and int and uint are the natural register size. Okay, so they are 64 bits for my machine. And it is using int for the y in here. Can I say i32? Like, can I just cast it like that? Does that work? Variable declaration must be an identifier got I32Y. No, it doesn't work like that. Okay. Can I put it in here? Say use int here. Can I do that? Oh no, it's supposed to be I32. Okay. Hold on. Oh yeah, it did work. Okay, that's actually great. So the grid is a bit big. So I'm gonna make it 24. Still a bit too much. 16 maybe. I'm keep doing, yeah, but it's a little bit off center. So I'm gonna do 20, and yeah, it fits actually perfectly. Okay, let's just do 20 then. I kind of don't like this color though. What other colors do we have in here? Gray, sky blue, dark blue, violet, dark purple. Let's try dark purple. Okay. Let's try violet. Violet. Yeah, that's a bit better. And can I do sky blue here? Here. I know that looks horrible. Um, maybe ray white. Uh, yeah, that looks alright. Okay. So now we need to program the snake, basically. So programming the snake is actually very simple. If you never done it, it has a very simple logic. So imagine that there is a snake head, and snake head moves in whatever direction you point it to. But the snake body, chunk by chunk, doesn't really follow the snake head. The only thing that follows the snake's head is the chunk that comes right after the snake head. The other chunks always follow the chunk that's in front of them, not the head. So you basically make a swap on the list of the chunks. The position of the next chunk equals to this one. So this is the head. Let's say this is the head, and there is another one here, and there's another one here. So this one goes here. This head moves, but this one goes here, the old head position, and the last one moves to this chunk's position, the old position of that chunk. So that's how it is. We basically swapped each item like that. And that's really all the logic a snake game has. So let's program that. But first we need to program the snake head. Snake head. I'm just gonna call it snake. And let's take advantage of Odin's dynamic array properties. Let's do something like this. Dynamic, and this is two I32s. The first thing in the list is the snake head, and this is the snake. I'm gonna just position the snake in the center of the grid. So this is going to be a grid divided by 2 and grid divided by 2. And that should just work. And we're going to be drawing the snake before the grid, so I want the grid to be above everything else. And we're just going to call, well, we're going to do this kind of the same thing, but we're going to do it like snake. We need the index of things, so this is the index in 0 to length of the snake. I think that's how we do it. Then we're going to say a do draw rectangle, and can I just say snake I xy here? Does that gonna work? Like, will it gonna expand? to the arguments. I guess we'll see. Probably not though. So this is grid, not grid, excuse me, cell. And let's do it in here like that. Cell. This is the width and height, and the color is going to be sky blue. Hopefully that's gonna look all right. And I forgot to do something like this in here. And whoa, okay, hold on. Color. Okay, wait. What's the first thing? Append. No procedures. Okay, I think I need to say this is 2i32s. Yeah, okay. So it didn't like this thing. Yeah, it doesn't like it like that. Okay. So that's the X. And no, we don't do it like that. We do times cell here. Snake I y cell. And yeah, that's not I, it's X. Okay. And yeah, that worked. Okay, great. So I'm gonna put this in here like that. Yeah. I actually want the head to be a different color. So I'm gonna start it from 1 and draw the snake head like this. 0 x cell 0 y cell cell cell, and I want the head to be actually a bit more different color, but which one would be maybe just blue is fine. We can just change that later if I don't like it. Yeah, it's alright, I guess. Or we can just do it the other way. Let's just do this sky blue and the body to be blue. Yeah. And yeah, because there is no more this loop is not executed right now because length is less than 1, so it's not gonna do it. It's exclusive. That's why it's not gonna execute it and crash. And so let's move the snake, I guess. Let's have a snake direction. Snake there. And that's I touch tools like this. And we're gonna say if RL is key down, RL right, then do snake there. 1 0, something like this. Else if I'm just gonna copy this. Else if we press left, we're gonna do -1, and that doesn't work. Okay, is key down? Oh, it expects an enum. Okay, so it's not like this. It's this, I think. And does that compile? It does. Okay. We can then do the other parts, I guess. So this is going to be up. This is going to be down. And up, down. And then we're going to move this thing. But we need a timer. We need a delay. And so it doesn't move so it doesn't move as fast. And I'm gonna just say this is the move time, or we can just call it update time, update timer. It's going to be a float, so it's a 64-bit. And it is going to be the maximum, the delay is going to be called update time. And we're just gonna say this is, let's just divide it by, let's just make it in milliseconds and say it like that, update time in milliseconds. And this is going to be I guess 20 FPS would be alright. And so we're gonna say if update timer is bigger or equal than update time ms, we're going to do our job. And at the end of this scope, we're going to set the update timer to be 0. In the else case, we're going to add to the update timer by the amount of the frame time or delta time. Some engines call delta time, some engines call frame time. Raider calls it frame time. Get frame time. Well, if I remember it correctly anyway. So and we're going to change the head position basically. We're gonna say snake deer 0 is the, well, not, no, snake 0 to be snake deer, and this is plus equals. I think normally this wouldn't work in C or Z because you cannot just add arrays together like that. But in Odin, there is civils, there is I basically treated arrays like a vector too. Or even though technically they're not, in other languages at least. In Odin, they are the basically same thing. And this makes it really easy actually. Because I never needed to define a vector too. I just said x, y, and it understood that because it's a convention. So just adding it like this, two arrays together, it also works seamlessly, which is actually very nice. So let's do this and see what's going to happen. Oh, it doesn't even work. Okay, it doesn't even compile. Mismatch types. Get frame time is apparently 32 bits. No, it's not double. Okay, so we're going to be make it a 64-bit then. 64-bit floats. And yeah, that works. Okay. So, but I want my snake to wrap around the grid. You see how it goes outside of the bound of the grid. I want to make it wrap around. Normally in the classic snake game, you die when you hit the boundary of the grid. But I don't like that actually. I like to wrap around. I think that makes more sense in a snake game, but we will see, I guess. I mean, what do you think? So, we're gonna just say, I guess we can just compare snake 0x. You see, normally in other languages, you would have to do something like this because it's a two-dimensional array. But in Odin, you can just do this. It's very convenient. This is bigger than the grid. We're gonna say snake 0 is 0. Snake's X position is 0, head position is 0. And else is 0, we're gonna say x is grid, I think. I think we need to say, we need to do something like this though, because it's otherwise going to be one more. Let's test this. Okay. And yeah, it does work. Okay, great. And let's do this for a y as well. No, search. Come on. That y. Yeah. Let's call this wraparound here. Around. And yeah, there we go. Okay, so we can wrap around now. Now, let's add another, let's add a chunk to our snake. So I'm just gonna add it like this in here for now to explain it a bit better. And I will add 2 of them. Let's just use the good old C syntax here. I'm just gonna call this I 0. This is the len of the snake. It's going to start from, or we can just use the actual range in the right. E in 0. We're not going from start from 0 because we already moved the head. So we're going to start from the body. It's going to be like this. So we're going to keep swapping them. The temp, well, snake I here is going to be the temporary. Oh, we need another variable. Okay, I'm just gonna call this old head, and temp is going to be old head here. Old is going to be, we need another variable. There's too much variables. This is going to be temporary, and temporary is going to be old here. And that's why we can keep swapping them out. Let's see if this thing works. And yeah, it does work. And it does follow it, and it does wrap around as well, because all it does, but as you can see, it doesn't really check for collisions. And we can just do that easily as well. We just literally check it in here. If the snake's head position equals to the snake eye here, it literally means they collided. And we can just say collision check here. Oops. Okay. Let's just wait for a bit. Let's just wait for 1 second and reset the game. Clear the snakes thingy and put this here as well. Recenter it, and we can just then do a break out of this loop, this for loop, and that's going to be our reset for now. Okay, so we don't have anything because at startup, for some reason, it doesn't see that, but okay, we'll see. Let's do the apple. It's going to be just 2 I32s, 2 integers. And I don't know how this random works in Odin though. How do we get a random number in Odin? Is it somewhere here? Do we have that? No. We can grep for it. Grep run something like this maybe. No, random. Um, I don't think any of this is. Well, there's standard. This POSIX random. Uh, but no, I don't think that's what we're supposed to use because there's a random generator in the context of Odin, if I remember that correctly. There's a helper for random. So there's big numbers in Odin and there's a random procedures in there. Okay, let's go into the core. Let's see, what do we have in here? Is there a random in here? Run, cd round. I don't know. I can't see anything. Is it in map? Round. Oh yeah, there is a random in here. Yeah, there is a random. Okay, round open. What do we have in there? Random number generators. And I'm assuming default random generator is assigned in the context already. Create use64. Is there anything that generates a range or there's uint 32, 128. There is uint 31. Oh, there is max thingy. Yeah, it's range based. Okay, this is what I want. Int 31 max. Okay. So we need to import this thing and it is in core math rand. Import core math rand. I think that's how we do that. And let's assign this like that. Rand. Was it int? What was it? Something max. Int 31. Do we have int 32? No, it's one bit less. There's 32, 31, 30, 63, 127. So it's one bit less. I guess it's for not to overflow the integer. Int 31 max. And the max is grid, basically. We can do something like this. Like this. Let's draw the apple as well. That's just going to be draw rectangle here. And apple cell, apple x cell, apple y cell. That's going to be the position, and the size of it is the cell, and the color is red. Let's run it and see if it works. Yeah, it does work. Is it random every time? Yeah, it does do random every time. Okay, great. So let's check for the collision with the head apple. So the only way to eat an apple in snake game is when the head collides with the apple. So we can just directly check for collision snake's head with the apple position like this in Odin. It's actually very convenient to use arrays like this. In C, you would have to do something like snake 0, 0, equals apple 0 and snake 0 0 was not 0, it's excuse me, it's apple 1 and then do like that. But this is literally the equivalent of this in C. It's very cool, very easy to do, very easy to use. So we collided it and we append a new chunk to the snake, and the new chunk's position, I guess we could just make it the old head. That should be fine because this is already going to sort them out. So it should be alright. Append to the snake, and it's going to be old head position. And we need to change the position of the apple as well. I'm just gonna copy it in here. Is this gonna work? I hope it is gonna work like that. Let's see. Yeah, it did compile. Okay. Is that a bit fast? It's a bit too fast. Okay, hold on. Let's make it 15 milliseconds. Yeah, that's a little bit better. Uh-huh. Does it? Okay, we do die, but it doesn't wait. It didn't wait for... Oh, because I put 0 in here for some reason. Okay. Let's see. Yeah, okay. Let's also reset the snake directory so it doesn't move instantly. And another cool thing in Odin is we could just do xy and equals to 0, and that will set the two will set both of them to 0. So we don't have to do kind of something like this. Like, I guess it's literally equivalent to syntactically this equals to this. Yeah. Little things like this makes your life easier, I guess. I don't know if it's that necessary to have a civil features like this in a general purpose language, but I guess it's alright for game programming. Let's see. And yeah, it doesn't move direct as soon as we reset. That's nice. Now let's add a score. I don't remember how to work with fonts in Raylib though, so let's take a look at that. Raylib. Raylib Odin. Draw text, was it? Draw texture, draw text. We do have a draw text function, and that's uses the Raylib's own font, I think. That's fine for our game here. So it takes a string, position, and the size and the color. Okay. So let's have a score here. How do we format a text? How do we format this though? I have no idea. Okay. I'm going to be using that. Let's open this here. So I think I saw something about formatting in here. Yeah. Formats, Odin. How do I format integers? Aprintln. Aprint creates a formatted string. Allocates using provide allocator. I guess that's it. We could use that. But how does the formatting works in Odin? Do we just use the C style formatting? tprint. What is tprint? It's using the temporary allocator. I guess that would make more sense for our case because we're going to be doing a temporary string. Yeah, okay. Let's just. Oh, wait. There's also a C string. Creates a format as a C string. So there is also then temporary allocator 1. How do we use it though? Is there any documentation here about how it parses it? I don't see one. Okay, I guess this is a good test for compiler. Let's just try to use it and see if compiler going to tell us anything about how to use this thing. We're going to try to use ctprint, I guess, because it does require a C string, right? Raw text. Raw text, come on. Yeah, okay, yeah, it does require a C string. Let's have it in here. And let's draw here on top of everything else. And let's call it rl draw text. Score at position is just going to be 0, 0. Font size, let's just make it 12, I guess. And let's make it black so for now so we can see the text. And the text is score. We're going to be using it with ctprint and it's in core fmt. I guess we need to import that as well. Core fmt ctprint. What does it take? Score. So I'm just gonna use the C style here, and the score is literally going to be the length of the snake. Yeah. And let's see if this works. Oh, it didn't work. No, it didn't work. Well, it does say 2, and it did put the integer there, but it didn't replace it with the %d. Oh, is it variadic? Hold on. Oh, so it is variadic. So it doesn't really format it. So it doesn't have a own parser in there, I guess. At least it doesn't say it in here. So it's literally variadic. You put it like this. Okay, that's also works, I guess. That works for us. And it's a little bit small. Let's fix that. Let's make it 24. It's still small. 28. Yeah, that looks a bit better. It does update. Yeah, it works pretty well actually. And it is above everything else we draw. That is great. And let's do something else. Okay. When you die, I want to do a little bit of state management now. When you die, I want a pop-up that says you died and wait a bit or just press something and restart the whole game. So we need states. So we need an enum for that. And let's define it in here. And state. or let's just say game state as the type. Um, do we use some? How do we? What's the name convention for this kind of stuff in Odin? I don't know. I'm just gonna do something like this. I think it was Ada case. Game state enum with let's just say alive and dead, and have a state in here. I'm gonna do something like this. Put this in here. Yeah. State is game state, and it is alive. Okay. So we're going to say game state is to be dead here. And if we are dead, we're going to be doing, should we switch on the state or, yeah, let's just switch on the state. Switch on the state and do a case here. Case of alive. And I'm just gonna put this thing in there. There we go. And in the case of that, we're going to be drawing something, but that's going to be in here. So let's do something like this in here. Let's do switch on here, states, and this is case of alive. And this is the case of dead. I want the score to be in the middle, a little bit above the middle when we are dead. So this is the grid divided by 2, grid divided by 2. We also need to subtract, I will subtract like 50 here, just arbitrarily. And we will need to measure the string length in here. So I think Raylib has a function for that. Yeah, measure text, I guess. Measure text. Let's have a font size, I guess. Font size. That's 28. Just replace that font size. And I guess this is going to be uppercase. Okay. So, and this is the font score length. Score width, I should say, I guess. Score width is going to be RL measure text score. And we're going to put font size in here. That's going to give us the size of this entire thing, the width of it. And we're going to just subtract half of it so it is dead center. And I'm gonna make this red. And let's wait, like, wait. What was the wait function? Wait time. Let's wait 3 seconds or 2 seconds. Let's see. Okay, it doesn't even compile. Was it like this? Oh, we don't, I guess we don't put this in here. Is it like that? I don't remember again. Apparently it's not like that. Okay, how do switch case works in this language? Enumerations. Oh, it goes after. Okay. that goes after. It is here. All right. Okay, so let's die. And we didn't see anything. The game is frozen right now. Yeah, okay. That didn't work. That didn't work. Why? We wait in here. State becomes dead in here. Oh, it's because we say wait. No, we don't. We're not supposed to use wait here because it's not gonna update the draws. Yeah. Okay. It still didn't work. It's still frozen. Did it? Do I still wait somewhere? When the case is like this. Hmm. Okay. Let's put this somewhere else because this is resetting the entire thing. Let's have another state, and that state is show score, I guess. And this should be show score. And when you're dead, that's the time we're going to do this thing and set the state to be alive. But when the case is show score, we're going to just, I guess, do nothing. In this case, though, this is going to be show score, and the dead case is just not gonna is just going to be empty. That might work. No, not really. It still frozen. It still freezes. Why does it freeze though? Oh yeah, because we need to wait. We need a wait timer again. Update time. Let's call this dead time. Or we could also just use the update timer here. But let's not do that. Let's have a show dead timer. Let's have a dead timer. It is 64 again, and that time milliseconds. This is going to be like it's going to be 1 second or 3 seconds. So we're going to keep incrementing in here. That timer plus equals this thing gets frame time, and if the dead timer is above the dead time milliseconds, we're going to change we're going to set the dead timer to be 0, and we're going to change the state. State is going to be dead. So then it's going to be over there, and yeah, all right. Let's see if this works. Oops. Well, it did reset successfully, but it didn't really show the text. Yeah, it does reset successfully, but that doesn't show the text for some reason. I think I'm doing something weird here. What is the... How do we print something in this one again? FMT printf, okay. FMT printf. Score width. What is the score width? Right, okay, let's see. Oh god. Extra 114? What? Oh, this is, oh, we're supposed to use like this in this case then. Can I just use print ln or something? Oh, okay, that works. It's 114. I think that's too much. um, hold on. That is too big. Let's die. Okay. And this is the position pose X is supposed to be. And this is the position Y. Let's copy that as well. To make sure we're not out of bounds of the grid and the screen. That's kind of bizarre. It's out of bounds. All right. Yep. Great. How did that happen though? Why is this out of bound? Grid. Oh, it's because it's grid. It's not supposed to be grid. It's supposed to be window size. Oh my god. Okay. Well, at least I didn't spend 4 hours debugging for a semicolon. Oh, yep, there it is. Okay, that works pretty well, but I want it to be a bit more above, a bit more higher. Uh-huh. Yeah, okay. And let's change this. Is there a dark red in Raylib? Dark. There's dark green, dark blue. Where is red? There is maroon. I guess maroon is dark red. Uh, I guess. I don't know. Okay. Yeah, it is dark red, but it doesn't look good. We need we need something lighter. Pink. What color would be great for this? They all suck, honestly. um when we dead, let's not draw the grid. Let's only draw it when we are alive. I guess that would be a better idea. And it would show up a bit better. Yeah, that shows up better. Yeah, okay. And let's make this a bit bigger. Let's make it 32. And I'm just gonna use black here because it still doesn't look great in that color. Uh, yeah, okay. That looks a bit better. And there is an extra space. So this thing also adds a space between the arguments. Um, I think I saw something about a separator in there. Yeah, you can define the separator as however you want. So a separator basically means between each argument, it's going to put that thing in there. And that's going to be, this is going to be it, I guess. Let's see if this works again. We can also add a sound, but I guess this is enough. We could make the apple draw order a bit higher because it doesn't show up when it's up when it generates underneath the snake. Let's do that as well. So we could just put a differ in there, and that will basically mean it's above everything else, but that's not what we want actually. We want above here, right? Okay, let's make it like this. Oh, I died again. Let's also print you died or something. Let's say you died. Or get good. Yeah, let's get good is better. Okay. I'm gonna do something like this again. And message is get good. This is going to be the message. And this is the message width. And this is just going to be here. Message width is going to be all that measure text. Message, right. Font size. There you go. Syntax are okay, that's not a plus. Equals, there we go. Message is not a C-string. It's not C-string. Can I just put sister here? C-string. I can. That's great. And it does work. Okay, I won't get good to be red though. I think that's going to be great. Ah, this thing is still too fast. Okay. Let's try something. Let's try to get as long as I can. Well, this is gonna get boring, I guess. But let's try. Ugh. Okay. And the apple did show above the snake, which is great. We saw that in action. And it doesn't seem to be appearing out of the grid, which is great as well. Oh, and I died. Okay. In an hour, we implemented this thing, and so overall, it's about 121 lines of code. And I think it's very nice to be able to use stuff like this, just compare the arrays like that. And even though it is an array and I didn't specify this has X and Y fields, you can just use it like this. You can swizzle them and you can assign them together. I think for games, this language is pretty nice. Anyway, this seems to be it, I guess. Thank you for watching, everyone. I guess I will see you on the next one, hopefully. Bye bye.